Hey guys, it's Mr. Aguilar over here. I'm finishing up the review sheet for the part 2. This is the second part to it, so we want to be able to identify several things about the function notation. Let me kind of move this around. We're going to go ahead and finish this up. Looking at these type of problems, we want to be able to determine whether their functions are minimum or maximums, and we determine that by looking at the a value. The first one that we're going to get here is going to allow me to write on this, hopefully. I'll reset this real quick. Sorry. And there. Let's try this again. The minimum or maximum for these are dependent upon the a value. What we first want to identify is if a is greater than 0, we have a min, and if a is less than 0, we have a max. So looking at these, we can identify this one as a max. This one is 5, so it's positive, so we say it's a min. And the bottom one, even though there's no value, we can still consider it a negative value, -1, which would also be a max. So just being able to identify these are going to be crucial for you guys to solve for some of these. The next type of problem that we're going to look at is finishing this up is the word problem. The word problem is going to be kind of interesting in seeing how we're going to do this. An object is thrown in the air and is modeled by the equation. The height over time is equal to -4.9 t squared plus 12t plus 1.8. What is the maximum height, and at what time is it at its maximum height? So what we're going to do here, this is solving for the maximum. So let's just say we need to solve for x is equal to -b over 2a, right? Solving for our variable. Our b in this case is -12. 2a is going to be 2 times -4.9. Do this on the board, so I'm going to kind of look at my reference for the board. If we check this in, we're actually going to get the solution of 1.22. And essentially what we're going to get here is we're getting a picture in which a ball is thrown up in the air. After so much time, what's the time it takes and at what height, or h of t, at that height is. So we're looking at the maximum height that this ball can go for. Once we have this, we're going to plug this back into our equation, h of 1.22, -4.9 t squared, or in this case, let's go ahead and just plug it in, 1.22 squared plus 12 times 1.22 plus 1.8. When you plug these values in, all you're going to get is your height at 1.22 is going to give you the value of 9.14. And it can either be feet or inches. We don't really know. It doesn't really tell us, or meters. We don't really know what it's providing us, so we just leave it as that is. So we have, after t seconds, which is 1.22, a max height of 9.14. So you guys need to be able to do these correctly and give me the correct values. 2 decimal places, preferably. Okay, so check those out, look those over. The next one we're going to look for is looking at increasing and decreasing, just, domains and range. We'll just do domain and range for these ones. Squishing everything down here gives me a domain value between -3 and 3. The range value for this is going to be lowest and tallest. This is going to be from -2 to 2. We do consider these functions. This is a function as we look at the vertical line test through here, and applies to all parts of these. So yes, it is a function. But we're looking at the sideway view, which is the horizontal line test. It's considered a 1-to-1. So 1-to-1, 1-to-1 is a no, because it passes through 2 points. We say it's not a function. It is continuous, meaning we can draw it from left to right without picking up a pencil, and that's what we want to be able to identify. It's increasing or decreasing intervals. We want to be able to look at the decreasing. So from left to right, it's decreasing here, so it's going to go from decrease from -3 to -2. Then we're going to increase, so I'll write it right up above it. Increase, we're going to go back up from here from -2 to -1. And then we're decreasing again, and that's going to go back down to my -1 to 1. And then we're going to increase again right here from 1 to 2, and then decrease our last time down here, which is from 2 to 3. So I can ask you all these different versions of increasing and decreasing intervals just by looking at the function itself. The next one to the right, we want to look at the domain and range values. Domain and range for this, our domain is going to go from the far left to the far right. So we're going to get from -2 to 2. The range value is going to go from lowest to tallest. So it's going to go from -2 to 2. Is it a function? Yes. A vertical line test passed through all of them. So function ftn is yes. Is it one-to-one? The answer would be no. A horizontal line through any of these would give us not a function. It does pass through it twice, even on the number line of x. So it would be no, like that. And then we can also identify the increasing and decreasing intervals. I'm just going to represent them on an arrow so I can get this video done. Increasing, we'll say that decreasing, totally not mathematical in any way, so please put increasing or decreasing. It's going to be decreasing on our first part from -2 to -1. We're going to look at it increasing from this part, so it's going to go from -1 to 1. And then we're going to decrease it from 1 to 2. And this is not inclusive because we don't include that interval, which is increasing by. This would also be decreasing by bracket like that. And then we'll keep doing it. So that's how you want to be able to do these, just be able to identify the types and values that we're looking for. So take care of that one. Pause it. If you need to go back, you can always do that. The next couple ones that we're going to be dealing with is complete the square or the vertex formula. I'm going to do one of each depending on what you guys want to do. I'll do the left-hand side, which is the completing the square. I'll do the right-hand side, which is the vertex formula. I'm going to set this equal to 0. I do want to complete the square. 0, I'm going to go ahead and add 23 to both sides, leaving a blank. Subtracting 23, sorry. We're going to simplify this one more step by taking out the greatest common factor. 6x plus something, 23. And then what we want to be able to do is divide out by our -6. So we're going to take our -6, divide out by 2, and square it. That's going to be our completing square term. It's going to be -3 squared, or just 9. So if I add 9 here, I'm actually adding 18 to both sides because I've got to balance out the equations. The integer or the variable constant value up in front of the polynomial is being multiplied by 9. So what we're going to get here is we want to be able to factor this and simplify out. This will be 2x minus 3 squared is equal to 18. So it's 5 negative 5. If we add 5 to both sides, this will give me this. So this is the equation I want to be able to use. My vertex would be 3 comma 5. And would it be a minimum or a maximum? We always look at the a to determine that. And because a is greater than 0, we actually have a minimum at the value of 5. Okay, minimum value of 5. We only care about the y output for that. The other version, which is a vertex formula, which you guys are most familiar with, the ones you guys like to use, especially for the word problems, you want to be able to do them that way, because using decimals and negative integers are going to kind of be difficult for you guys to do. So I'm bringing up my calculator here. Our calculator here is going to help you determine the values. So x is going to be negative b over 2a. Negative b is going to be 30 over 10, which is just 3. So x value is going to be at 3. So it's going to be looking at our vertex for 3. I got to find the other one, but plugging it into the equation. So f of 3 is going to help us determine that. So 5 times 3 squared minus 3 times 3 plus 49. And mind you, we have a minimum value here. 5 times 9, which is 45, minus 90, plus 49. So I'm looking at here 45 minus 90 plus 49 is going to be equal to just 4. So we have our value equal to 4, which is our function value. Okay. So look at that. In this case, we also have a minimum value because our a value in this case, again, is positive. So we do have a minimum value at these three. So two ways of looking at the problem. You probably could have factored that out and done the same thing. Subtract out 49, divide out, square it. Would have given you a bigger number, but we could have still done it. So keep that in mind as we're doing these type of problems and solving. I believe that moves us to the back side of these, which I believe is our last set of problems. So please make sure you guys look at these. Now, when graphing these, it's important that we look at the domain and range values and how we graph these. We have different types of functions for each representing these different types of domains and ranges. Looking at number 3 being a restricted domain for when every value is greater than 0. So we want to be able to identify those. The first thing we're going to look here is I want you guys to be able to just graph these basic forms of these functions. So we talked about these today. So we go up like this for a quadratic in some form. The cubic is going to look like a sideways S essentially. And on the square root, it's going to look something like that. And there's ways and methods to solve these out, and I'm hoping I'm going to teach you guys those right now. The two things that we need to graph this are a value, which in this case our a value for our function is 1, and we need the vertex. Our vertex is going to be 2, 4. From those, we're going to be able to graph it, and we're going to be able to describe the domain and range values. In this case, because a is 1, it's also a minimum. It's going to be facing upward. It shifts into the right by 2, up by 4. So I need you guys to be able to give me those as well. Going over 2, up 4 gives me a function value here. Okay, that is my vertex. The vertex are always key when doing these. Now, because our a is 1, we're always going to go 1 away from each side of these and go in the same direction. If it was negative, we would be going down. If it was positive, we'd be going up. Looking at this, I'm going to go over 1, up 1, over 1, and up 1 to graph my function. It doesn't need to be super accurate. I just want you guys to give me something like this. If it was negative 1/2, I would go, or negative 3 and negative 4, we'd go over 1 and then down. So if this was negative 3, we'd go over 1, down 3, and be a closer graph like that. But in this case, we don't have something like that. So if you want me to go over problems tomorrow to go on Friday, I'll probably go over those to help you guys out, especially looking at the domain function values. For this case, we can look at our domain. In this case, it's all real. Or on our interval notation, negative infinity to infinity. And we're going to start that at 4 and go upward. So it's going to go from 4, comma, infinity. So that's our domain value for this one. The cubic function is just like the function for the quadratic. The only difference is we do opposite. We do 1 over, so 1 over 1 up, 1 over 1 down. So it's going to be kind of reversed. It's going to look like an S. So one's going to be kind of going like an opposite way to each other. So looking at the top one, let's find the vertex. So our a is negative 1, so we're going to be flipping them. And the other version of this, of the vertex, would be 3, comma, negative 1. So we're going to go over 3, down 1. This is our vertex right here. Our a is negative 1, so I'll be going over 1, down 1, back 1, up 1. Because it is a negative function, we are going down where like that. So we're going to look something like that. Now, the good thing about this domain that we're looking at is for the functions going in both directions, still negative, and still positive, because it gives us an X on both the values. It'd be also squishing them down. We're going to get an arrow here, arrow up, and an arrow down, all going in all directions. So infinity to all these different parts of the function. The last one is what we're looking at being restricted. And we talk about being restricted whenever we have a square root or 1 over a rational function where we have an X value underneath it. For this one, we still need the a. The a value in this case is 1. And when plugging in, we're also going to get negative 1, 4. So this is a different way of looking at it. Now with this one is graphed a little bit differently. We want to look at perfect squares. So when graphing 1, 2, 3, 4, 1, 2, 3, we want to be able to graph this accurately. So let's say the vertex of this, let's look at a square root of x. We can graph 3 easy points by doing 0. 0 squared is just 0. Perfect square root of 1 is just 1. And then the next perfect square would be 4, right? Square root of 4 is 2, so we'd go over 4 up 2, okay? And that changes when you have the a. So if it was an a value, and we had the a equal to 2, we would go over 1. So let's say when a is equal to 2, and we had to graph this. So this is the original, right? If we had to graph this with an a value, we'd still be at 0. 0 squared is still 0. When we go over 1, what's 1 times 2? It's going to be 2. Okay, so that's going to be the next one. And then we do the square root of 4 is 2. So 2 times 2 is going to be 4. So it's going to get wider this way. So there's always ways to graph this. If it was a negative 2, it'd be flipped downward, and we're still going to be able to graph these. So looking at this, let's graph this. Let's see if this works out. Back 1, up 4 is here. That's our function. At 0, 0, we're going to be good. So use the origin, use that center, the vertex point as your center. Go 1 over 1 up, right? Perfect square root of 1 is 1. Over 4, 1, 2, 3, 4, and now we're going to go up 2. This is going to help us graph the second one, which is going to look something like this. Okay. If we would have to go to the next one, the perfect square, the next one would be 9. Square root of 9 would be 3, so we'd have to go over 9 and up 3 for this point for it to go through. So that point is there. Let me just graph that if you guys want me to. Sorry, it's hard to graph at this little angle. So we have a graph there. That's more accurate if you want to have it that way. So the range value is actually different, right? Our domain value goes from -2 or -1 to infinity. So -2 to infinity. And then we're also restricted on our range in which it starts at 4 and goes upward. So -4 bracket, which is inclusive, to 10. Sorry, not 10. Stupid. Infinity. So these are the ways you want to graph them. We'll look at more graphing of these types of functions. Please check these out. Let me know what you guys think. You guys take care, guys. Bye. That's the bell. I'm going to post it right now.